And the last thing to do before moving on to a multi-layer model is to see how this performs with interactions. So we're still going to have a linear model, but we're going to have interaction terms. So let's uncomment this, and you can see that now we have interactions of x0 times x1 and x0 times x1 times x2. So let's recreate our data by running that, and we need to change actually nothing. We don't need to change anything. Let's leave it at 2 nodes for our input layer, and then let's go ahead and run this. And we can see that we have a really high loss. It's actually a lot higher than our absolute mean value of our data. Let's do one more thing. Let's increase the number of nodes, and we'll increase that to, say, 20. Let's go ahead and run this again. So it's a bit better, but we're still at a loss that is much greater than the absolute mean value of our data. So now we can move on to creating a multi-layer model that we can, you know what, actually, I should have run that at 32. So we have an improved loss, but it's still greater than the absolute mean value of our data, which is basically 70. Now that we've done that, let's go ahead and start creating our multi-layer model. We need to add a new hyperparameter, so let's add nNodes2, and we're going to set that to 32. And let's see, our output can remain the same, our batch size, input, so we'll leave everything the same for that. And let's see, what else do we need? Let's create a new layer. Okay, so we need to create weights for the second layer, and let's change this nInput to nNodes1. And then we want the second dimension to be nNodes2, and then we need to change the first dimension on our output weights to nNodes2. And then we're going to do basically the same thing for biases. So we can call that B2, and this is going to have nNodes2. All right, so we've created weights and biases, basically just the parameters for our model with 2 hidden layers. And now we need to create the second hidden layer and then connect that appropriately to our output. So for this one, instead of X, we need that to be A1. And while we're at it, let's change the output to A2, change this to A2, and then change this to Z2. Okay, so let's see, weights need to be W2 and bias needs to be B2. And then our A2 needs to operate on Z2 rather than Z1. Okay, so everything looks good there. So let's go ahead and run this again, and it should take longer, but not too long. Okay, so you can see that we have dramatically better performance on this. Again, the absolute mean value of our data is roughly 70, but now we're within plus or minus 50% of the value of the absolute mean value of our data, which is a lot better than we were doing with the single hidden layer. So even though we have that output layer, it's still not doing great if we only have a single layer at picking up on these interaction terms. So we don't have time for the next portion of it, which is quadratic interactions, but you could always create another model yourself, add a third layer, and try to learn those terms. And you may want to play with the learning rate as well as the number of nodes. Okay, so we'll see you next time.